All right, let's kick things off with a question that I know sounds like it's straight out of science fiction. But what if it wasn't? What if our most important buildings, like hospitals, could actually talk to us?
And I'm not talking about the fire alarms or the overhead announcements. No. I mean the building itself, the actual structure. Can you imagine if the steel, the concrete, all the systems kind of running through its veins? What if they could tell us exactly how they're feeling and what they need?
So just imagine for a second, the hospital's facility manager gets a notification on their phone. It says this: "I'm feeling too much vibration on the 5th floor." But here's the kicker. It's not from a person. It's from the building itself, from its own network of sensors. That's not just a weird message. It's a specific, actionable piece of data about its own health.
Okay, or how about this one? Now we're not just talking about the skeleton of the building anymore. We're talking about its vital organs, right? The really complex systems that keep the whole place running. This is the building literally giving us a heads up that there's a problem way before a catastrophic failure happens.
Now this is where the idea gets genuinely mind-blowing. The building can report on stresses that are completely invisible to you and me. Think about it. Tiny little seismic shocks that happened overnight. We wouldn't even notice, but the building feels it, and it can tell us its frame is fatigued. I mean, this is proactive health monitoring, but for a whole building.
So here's the thing. The big takeaway is that these massive critical buildings are just buzzing with information. They're alive with data points, vibrations, temperature changes, tiny shifts in the foundation, you name it. But for the most part, they're completely voiceless because nobody's really listening. Nobody's putting all that information together. Well, until now.
All right, so how do we teach a building to talk? Well, it's not magic, even though it kind of sounds like it. It's actually this incredible fusion of structural engineering and, you guessed it, artificial intelligence. Let's dive into the core idea that's finally giving these silent giants a voice.
The absolute key to all of this is something called a digital twin. So what is that? Just think of it as a perfect, living, virtual model of the hospital, right there on a computer. But, and this is super important, it's not just a static 3D drawing. It's a living, breathing digital copy that's being updated in real time with data streaming in from thousands of sensors placed all over the real building.
So what exactly is this digital twin reporting on? Well, first up, its own body, its structural health. The AI is constantly sifting through all that sensor data. It can ask things like, is the frame bending even a little bit? Are those tiny cracks getting bigger? What about that unexpected settlement in the foundation? And it can tell us exactly how it's behaving after something like an earthquake. We're talking about finding problems long before a human inspector with a clipboard ever could.
And it's not just about the structure. The digital twin also keeps a close eye on all the building's internal systems. You know, its mechanical and electrical guts. We're talking about HVAC performance, pump efficiency, the health of the boilers, and something absolutely critical, the readiness of the backup generators. The AI can spot anomalies and predict a failure weeks or even months before it happens. And in a hospital, well, you can imagine. That capability is literally life-saving.
You know, this intelligence also has a huge impact on the people inside. This is about operational performance. By analyzing data on, say, patient flow or how the elevators are working, the hospital can actually optimize its own day-to-day operations. It can make things safer, more efficient, and ultimately help it do its most important job even better, taking care of people.
Okay, so we've got the big idea down, right? The digital twin. But let's get into the really cool stuff. I want to give you 5 glimpses of tomorrow. 5 really specific, almost mind-bending applications that show just how game-changing this technology is. This is where it stops being theory and starts feeling like the future has arrived.
First up, get this. AI that can predict earthquake damage. A hospital's digital twin can run thousands of simulations of future earthquakes. It uses some seriously advanced AI to predict exactly how the real building would react, pinpointing all the weak spots. And that means they can be fixed and reinforced before a disaster ever strikes.
Number 2 is, wow, real-time crack growth prediction. The AI doesn't just see a crack that's there now. It can analyze all the data, the stress, the material fatigue, the humidity, and predict where that crack is going to be next month. It's literally forecasting damage before it's even visible to the human eye. Just think about that for a second.
Okay, number 3, AI-driven emergency response. Now picture this. In a real emergency, like a fire or an earthquake, the building itself could automatically figure out the safest way for people to get out. It would generate and constantly update evacuation routes based on which parts of the building are actually safe in that exact moment. So, if one hallway is blocked or compromised,
Boom, the system instantly tells everyone to take a different, safer path.
Then there's number 4, fully autonomous maintenance. The system can basically start to heal itself. We're talking about a future, and it's not that far off, where you have autonomous robots guided by the digital twin's AI. They're constantly crawling around, detecting corrosion, scanning for weak spots, and even making repairs, all before a human being even knows there's a problem.
And finally, number 5. This might be the best way to think about the whole thing. The AI becomes the building's chief structural doctor. The hospital is now the patient. Its digital twin acts like a living medical record, you know? It tracks its entire history, its current vital signs, any symptoms it's showing, and it gives a long-term prognosis. The AI is literally its doctor.
So you see, this is so much bigger than just one building, or even just hospitals. We are on the cusp of a whole new era, an era where our critical infrastructure is no longer just this passive, silent thing. It's becoming active, intelligent, and it's learning to report on itself.
I mean, think about it. This technology is going to be everywhere. Our bridges will be able to tell us when they're getting tired. Our power plants will warn us before a blackout hits. Our tunnels, our airports, they'll all be talking, optimizing themselves in real time. Pretty soon, every single critical structure in our lives, maybe even our homes, will have a voice.
And that brings us right back to where we started. After everything we've just walked through, that original question, can hospitals talk? It almost seems a little quaint now, doesn't it? Because the answer is yes, the technology is here. The capability isn't science fiction anymore.
So the real question has changed. It's not about the can we anymore. The real question is, are we ready to listen? And that's the big idea I want to leave you with. We now have this incredible ability to give our entire world a voice. But listening, well, listening is hard. It requires a huge shift in how we think about our environment. The challenge isn't about the tech anymore. It's a human challenge.
Because ultimately what we're really talking about here, what we're witnessing, is the birth of a completely new kind of entity. It's this fusion of a physical thing, like a building, and a powerful artificial intelligence. And what that creates is something so much more than just a smart building. It creates a building that is, in a very real and practical sense, alive.